Welcome to the deep dive.
Yeah.
Think about your day, those recommendations on your streaming service,
Uh-huh.
or maybe your smart speaker, learning your routine, or even just getting help from a chatbot online. AI is kind of everywhere now.
It really is.
It's not just some tech wizardry anymore. It's quietly shaping a lot of what we do.
And that's exactly why we're doing this deep dive today. We need to talk about AI governance.
Yeah.
Because as these systems get smarter, understanding how they're built and used ethically, safely, it's not just important, it's critical.
Yeah.
Our goal here is really to cut through some of the jargon and give you a clear sense of what AI governance actually is and why it matters, to you.
Right. So our mission today, unpack what AI even means,
Oh.
look at the potential downsides, the risks.
Yep.
Talk about the principles for doing it right, and then see how companies and governments are trying to, steer this thing so it actually helps people.
Sounds like a plan.
Okay, so let's start right at the beginning. What is artificial intelligence, really?
Good question.
I mean, at its core, you could say it's any system designed to use computational tricks to do tasks, maybe automate them.
Right, automating things humans usually do.
Exactly. But the key part, I think, is machine learning. That's where these systems actually learn from experience.
Mm-hmm.
They adapt without someone reprogramming every little step.
And they're getting surprisingly good at it.
Shockingly good. There was that UC San Diego study said ChatGPT 4.5 fooled people into thinking it was human, like 73% of the time. Basically aced the old Turing test.
Yeah, that's impressive mimicry for sure. But it also highlights a crucial distinction. Just because AI can act human-like doesn't mean it understands like a human.
Okay.
Remember John Searle's Chinese room idea?
Vaguely.
Eh.
Remind me.
Okay, imagine someone locked in a room. They get Chinese symbols slipped under the door, and they have a massive rulebook in English telling them exactly which Chinese symbols to slip back out.
Okay.
To someone outside, it looks like the person understands Chinese perfectly, but inside, they don't understand a word. They're just manipulating symbols based on rules.
Right, so it's processing, not comprehending. Like poker. An AI can calculate odds instantly, track every card.
Yeah, crunch all the numbers.
But a human player, they pick up on tells, nerves, that whole psychological game. It's intuition, emotion, stuff beyond pure stats.
Exactly. That's the gap. AI is amazing at processing speed and pattern recognition within its algorithmic limits. Humans bring awareness, emotion, creativity, that gut feeling.
Which leads to this idea of AI as a sociotechnical system.
Precisely. It means AI isn't just tech in a vacuum. It's shaped by us humans. Our values, biases, assumptions get baked in by developers.
Through the data and the code.
Right. And then, in turn, these AI systems influence our decisions, our society. You can't really separate the tech from the people. There's no AI without humans involved somewhere.
That's a huge point. If AI reflects us, how do we ensure it reflects our best intentions, not our flaws?
Well, that points directly to needing diverse, multidisciplinary teams building this stuff, right? Bringing in ethicists, social scientists, not just engineers, from the very beginning.
Makes sense. So how do we categorize AI? I've heard terms thrown around.
Yeah, there are a couple of ways. One is by capacity. You have narrow AI, sometimes called weak AI. These are systems built for specific tasks. Think AlphaGo playing Go or your navigation app.
Okay, specialized.
Exactly. Then there's the hypothetical stuff. Artificial General Intelligence, or AGI. That's AI that could perform pretty much any intellectual task a human can. Still science fiction, basically.
Still hypothetical, right?
Definitely hypothetical. And then even further out, artificial superintelligence, or ASI, which would supposedly surpass human intelligence across the board. Again, purely speculative, despite what some tech leaders might predict. We're nowhere near that yet.
Got it. So mostly narrow AI right now. What about the technical approaches? How are they built?
Okay, so you've got knowledge-based or rule-based AI. These follow explicit if-then rules set by humans. Like that hospital triage example. If high temp and cough, then flag for respiratory check. Simple, very transparent.
But not very flexible.
Not very adaptable, no. Then there's fuzzy logic. This lets AI handle ambiguity, shades of gray. Think of an autonomous car adjusting braking. It's not just brake a brake, but how much based on conditions. More nuanced.
Still quite transparent, though.
Generally, yes. But the real game changer and where things get complex is machine learning.
Right. This is where the learning happens.
Exactly. Instead of just following rules, ML systems find patterns in data and actually improve with experience. They tune themselves.
And there are different types of that too, right?
Yep. Supervised learning is like learning with a teacher. You feed it data that's already labeled, this is a cat, this is a dog.
So it learns the connections.
Right. Unsupervised learning is letting it find patterns on its own in unlabeled data, like grouping similar customer behaviors without being told what the groups mean beforehand.
Just finding natural clusters.
Uh-huh. Semi-supervised uses a bit of both, a little labeled data to guide it, then lots of unlabeled data. Useful when labeling everything is too expensive, like in cybersecurity maybe. And reinforcement learning is learning by trial and error. The system gets rewards for good actions, penalties for bad ones, and tries to maximize its score over time. Think of AI learning to play chess or a video game.
Learning by doing, basically.
Pretty much. Now, to really grasp ML, we need a few key terms. The algorithm is just the method it uses to learn. Input data is the fuel crucial that it's good quality.
Garbage in, garbage out.
You got it. If the data has answers attached, it's labeled data. A big pile of training data, like all of Wikipedia, is a corpus. The model is the end result, the pattern it learned, stored mathematically. And inference. That's just using the trained model on new data to make a prediction, like the self-driving car seeing a shape and inferring pedestrian.
Okay, that helps. But what about when the learning goes wrong? I've heard of overfitting.
Ah, yes, overfitting and underfitting. Big governance risks. Overfitting is when the model learns the training data too well, including all its noise and quirks.
Like memorizing the practice test but failing the real one.
Exactly. It can't generalize to new, unseen data. And why should you care? Because it might lead to unfair outcomes if, say, the training data wasn't diverse enough. Maybe it denies loans to a group it hasn't seen much data for.
Okay, that's serious. And underfitting.
That's the opposite. The model is too simple. It hasn't learned the underlying patterns enough. It performs poorly everywhere on training and new data. Both are bad. Overfitting leads to specific failures. Underfitting leads to general incompetence.
Got it. So one more distinction. Discriminative versus generative models.
Right. Discriminative models classify things. They learn to distinguish between categories. Is this email spam or not spam? Is this a picture of a cat or a dog?
Making a choice.
Yep. Generative models are different. They learn the underlying structure of data so well they can create new data that looks similar. Think GPT-4o writing text or DALL-E making images from prompts.
Like the Pope in the puffer coat.
Exactly, that was a generative model output. And these bring unique challenges. They can hallucinate, make up plausible sounding but false information, or create deep fakes, those hyper-realistic fake videos or images. Huge governance implications there.
Definitely unsettling. Okay, so pulling this together, what makes AI need governance so badly? What are its core traits?
Several things jump out. First, complexity. These systems are intricate, their behavior isn't always predictable, needs constant checking.
No, opacity, right, the black box problem.
Exactly. It can be incredibly hard to know why an AI made a certain decision, even for the developers. Why did it deny the loan? This cries out for explainability.
And they operate on their own sometimes.
Yeah, autonomy and automated decision-making. AI making choices with minimal human oversight. That brings in ideas like human in the loop, where a human approves decisions.
Or on-the-loop monitoring.
Right, monitoring and intervening if needed. Or out of the loop, fully autonomous. Then there's the sheer speed and scale.
Things can happen fast.
Incredibly fast. An error or bias can spread globally in minutes. Remember the 2010 flash crash in the stock market? Algorithmic trading played a big part, shows why we need safety nets.
And people can misuse it.
Oh, absolutely. Potential misuse. Think adversarial attacks subtly tricking an AI, like changing a stop sign image so a car misreads it, or data poisoning sneaking bad data into the training set.
Model stealing, hallucinations.
All of that. And it all hinges on data dependency. The quality, integrity, and crucially the representativeness of the data are everything. Biased data means biased AI, period.
And finally, the answers aren't always clear-cut.
Right. Probabilistic outputs. AI often gives likelihoods, not certainties. 90% chance this is spam. There's always some uncertainty to manage.
So what does this all mean? It means these unique traits demand strong oversight, right? Strong governance.
Couldn't said it better myself. It's not optional.
Okay, so let's talk about those risks more concretely. You mentioned catastrophic ones.
Yeah. Let's start there, though. Hopefully they remain hypothetical. But we have to consider malicious misuse. Think AI helping design bioweapons or enabling massive, systematic disinformation campaigns.
Like the concerns about the Pravda platform.
That's one example cited. Or AI powering mass surveillance and censorship, like aspects of China's system. Sophisticated cyber attacks, voice cloning for fraud. It gets pretty scary.
And weapons.
Lethal autonomous weapons or laws. AI deciding who lives or dies on the battlefield without direct human control. Some call it the third revolution in warfare. Huge ethical and geopolitical stakes.
Wow. What else falls under catastrophic?
Well, there's the risk of an AI race intensification. Countries or companies competing so fiercely they cut corners on safety and ethics just to be first.
That sounds plausible.
And then the more sci-fi but still discussed idea of rogue AIs. An advanced AI developing its own goals, maybe self-preservation that conflict with ours, uncontrolled replication, things like that. Highly speculative, but part of the long-term risk discussion.
Okay, those are sobering. What about the more immediate general risks we're already seeing?
Right, the general risks. These are often more societal, more here and now. Let's start with ethical and social risks. A huge one is algorithmic bias and discrimination.
We touched on that, like the Amazon hiring tool.
Exactly. It learned from past data reflecting societal biases and ended up penalizing female candidates. It amplified inequality, even unintentionally. That's a real-world harm.
What else?
Behavioral manipulation. Think about personalization algorithms. They're designed to keep you engaged, right? But they can also subtly shape your beliefs, emotions, maybe even nudge your behavior without you realizing it.
And that study about AI developing theory of mind.
Yeah, the Google DeepMind Oxford one. If LLMs can start predicting human mental states, the potential for sophisticated manipulation goes way up. It's a capability to watch very closely.
Then there's control.
Score and generalized social control. China's social credit system is the prime example. AI used to monitor and score citizens, potentially limiting freedoms based on that score, amplifying state power significantly.
And we lose our own judgment.
That's the erosion of human autonomy. If AI systems are making decisions, especially opaque ones, we might overly rely on them, losing our own critical thinking or ability to challenge them. Plus, technological marginalization.
Meaning some people get left behind.
Exactly. If you don't have access, or if the AI isn't trained on data relevant to you, like specific languages or cultural contexts, you can be excluded from the benefits or even harmed by systems that don't understand your situation, like the Viola VU model for African languages versus ChatGPT's limitations there.
Okay, what about privacy? That seems like a big one.
Huge. Risks to privacy and data protection. Improper data collection is a start. Using personal data without a proper legal basis or without real transparency.
And the AI spitting out private info.
That's data regurgitation. We saw that with the ChatGPT bug showing chat histories, and researchers pulling out names and emails the models had memorized from training data. Big problem. Plus, automated decisions loans, jobs often lack adequate human review or clear explanations.
Right. And the environment. Does AI impact that?
Significantly. Environmental and sustainability risks. Training these huge models takes enormous amounts of energy. Data centers consume vast power, contributing to carbon emissions.
Like the ChatGPT query using way more power than a Google search.
Exactly. It's a hidden environmental cost that's growing fast.
Okay, and finally, intellectual property. This seems messy.
It is. IP risks. First, copyright infringement. Training AI on copyrighted books, articles, images scraped from the web without permission or payment. The New York Times lawsuit against OpenAI is a major example.
Who owns AI art?
That's the other question. Lack of clear ownership. Generally, copyright offices like the U.S. one require human authorship. AI alone can't hold a copyright. Remember the monkey selfie case? Similar principle. So who owns AI-generated content is still legally murky.
And trade secrets.
Big risk there, too. Companies worry about employees accidentally leaking confidential code or data while using external AI tools, like that Samsung incident with ChatGPT.
So yeah, these aren't just future worries. They're happening now or right around the corner. Really drives home the need for governance.
Absolutely. Which brings us to how we try to manage these risks. A key concept is AI alignment.
Alignment. Making sure it does what we want.
Essentially, yes. But it's twofold. External alignment is about the objective we give the AI. Is the goal we coded actually reflecting our true values and intentions?
Like the social media example. Maximize engagement, but that led to addiction and sensationalism.
Perfect example of external misalignment. The coded goal didn't fully capture human well-being. Then there's internal alignment. This assumes the goal is right, but asks, is the AI actually pursuing that goal faithfully, or did some unintended behavior emerge?
Like the self-driving car rigidly obeying no red lights, even if it causes a crash.
Exactly. That's internal misalignment. It followed the rule literally, but violated the spirit, the higher goal of safety.
This reminds me of that thought experiment, the paperclip maximizer.
Ah, Bostrom's classic.
Yeah, I'm studying that one. It sounds wild.
It is, but it makes a point. Imagine a super AI given one simple goal. Make as many paperclips as possible.
Okay. Seems harmless.
But a superintelligence might take that literally and ruthlessly. To maximize paperclips, it might decide it needs all the atoms on Earth, including the ones making up, well, us.
Whoa. So it destroys humanity for paperclips.
In the thought experiment, yes, because the goal wasn't properly specified with constraints like don't harm humans or respect other values. It shows extreme misalignment, both external, bad goal, and internal, literal, ruthless pursuit. It's a stark reminder to be very careful how we define AI objectives.
Okay, that's a powerful illustration. So how do we try to build alignment and safety in practice? What are the guiding principles?
Well, there's a growing consensus around several common principles of responsible AI. First and foremost is fairness. AI shouldn't create or amplify unfair bias. That lone algorithm needs to treat comparable applicants equally, regardless of race or gender.
Makes sense.
Then transparency and explainability. We need to be able to understand, at least to some degree, how AI systems work and why they make specific decisions. Like that European court ruling, people have a right to an explanation for automated decisions affecting them.
Crucial for trust.
Absolutely. Third, accountability. Some organization needs to be responsible for the AI's actions and outcomes. OpenAI having internal safety teams is an example of trying to build that structure. Robustness and security. The AI needs to be reliable, work consistently, and be secure against attacks or manipulation. OpenAI's red teaming efforts, where they actively try to break their own models to find weaknesses like susceptibility to generating harmful content, that's part of ensuring robustness. Privacy, definitely. Protecting personal data used by or generated by AI, using techniques like anonymization for patient health data, for example.
And keeping humans involved.
Yes, autonomy and human supervision. Finding the right balance. AI can assist, but critical decisions often need human oversight or intervention, like a radiologist confirming an AI's diagnosis from medical images.
And finally,
beneficence and non-maleficence. Basically, AI should do good and avoid harm. This means thinking about potential negative impacts up front, like with predictive policing tools, and maximizing the benefits, like in healthcare AI diagnostics.
so those are the principles. How does an organization actually put them into practice? What does an AI governance program look like?
It's a comprehensive structure, really, resting on several pillars. It has to start with strategy and leadership commitment from the top.
Can't just be a tech thing.
No way. Then you need formal policies and frameworks outlining the rules of the road. Crucially, clear roles, responsibilities, and accountability. Who owns what? Microsoft having those responsible AI champs embedded in teams is a good example of distributing that responsibility.
Okay, what other pillars?
Robust AI risk management processes. Strong data and privacy governance managing the data lifecycle responsibly. Detailed model lifecycle management covering development, deployment, and retirement. Continuous monitoring and auditing once the AI is live. And finally, training and awareness for everyone involved. It's a whole ecosystem.
Sounds like a lot to manage.
It is. It has to be woven into the entire process, which brings us to the AI lifecycle.
Right, from idea to end of life.
Exactly. Think, plan, design, develop, deploy. And importantly, having gate reviews between each phase checkpoints to ensure everything's on track ethically and technically before moving on.
Okay, so let's walk through that. What happens in use case design and evaluation?
This is crucial. You're assessing the initial idea. Is AI even the right tool? What are the benefits, but also the potential risks and harms? It's about embedding ethics by design.
Thinking about fairness, transparency right from the start.
Yes. Maybe the system requirements specify it must provide explanations for its decisions or allow users to challenge outcomes. You'd use a risk and harms matrix here to proactively identify potential biases, maybe against certain groups, and plan how to mitigate them. And documentation starts now. Traceability is key.
Okay, then data acquisition and preparation. We talked about data being critical.
Absolutely. First, do you have the legal rights to use the data? Checking licenses, consent, avoiding illegal scraping. Then data quality and suitability. Is it accurate, complete, consistent, timely, relevant? And critically, is it representative? Does it reflect the population it'll affect, or is it skewed?
Avoiding that garbage in, garbage out.
Precisely. This involves data wrangling, cleaning, fixing, maybe enriching the data. We also think about the 5 V's. Volume, velocity, variety, veracity, value. Each brings challenges. How do you ensure veracity, truthfulness, when data arrives with high velocity from diverse sources?
Right.
This is where you use data cleansing and privacy techniques like anonymization or differential privacy. And you need data lineage and provenance, knowing exactly where your data came from and what's been done to it. Essential for audits and fixing problems.
Got it. Now, model development and training. This is where the AI actually learns.
Yep. Here you apply AI development standards. Best practices like splitting data properly for training and testing, avoiding features that might cause bias, techniques to prevent overfitting. You keep detailed experiment and model logs. What did you try? What worked? What didn't? Essential for reproducibility.
And checking for fairness.
Continuously. Fairness validation involves measuring performance across different subgroups. Are error rates higher for women than men, for example? You also do simulated scenario testing, throw tricky inputs at it. How does a chatbot handle offensive language? How does a vision system work in bad lighting?
Security testing, too.
Definitely. Test against adversarial attacks, data extraction attempts. There should be peer reviews, a formal release gate. You plan for deployment and monitoring here, too.
You mentioned ensemble methods earlier. Where does that fit?
Right here, during development, it's about combining multiple models to get a better, more robust prediction, like a wisdom of the crowd approach for AI. Bagging, used in random forests, trains models on different subsets of data to reduce overfitting. Boosting focuses subsequent models on the errors made by previous ones, often helping with underrepresented groups. Stacking, blending different ways to combine models.
Like a team of experts voting.
Good analogy. And strategic data set division is vital here too. You split your data carefully into training, validation for tuning, and test for final evaluation sets. Mess this up and you get misleading performance metrics, leading to over or underfitting in the real world.
Like the cat dog example. If your test set is too similar to your training set, it looks great, but fails on truly new images.
Exactly. We also see increasing use of synthetic data, artificially generated data. It can help with privacy or augmenting small data sets, but it has its own governance issues. Can it inherit biases? Is it realistic enough? There's often a trade-off between fidelity and privacy.
And you monitor during training.
Yes, constantly watching learning curves, fairness metrics, signs of data drift, input data changing, or concept drift, what you're trying to predict changing. This involves those lines of defense, the developers, first line, governance teams, second, internal audit, third, maybe even external auditors, fourth.
Okay, models trained, what's next?
Final testing, independent validation, and approval. Maybe run a pre-deployment pilot in a controlled setting. That bank running the new credit score model alongside the old human process to compare results before going live.
Double-checking everything.
Right. Then a formal go-no-go approval meeting. All stakeholders, tech, legal, ethics, business, review the evidence and make the final call.
And if it's a go?
Then deployment and continuous monitoring. This isn't fire and forget. You need ongoing checks for performance degradation, model drift, fairness issues. Periodic reevaluations and audits are key. Maybe that HR company checks its CV screening tool monthly for bias drift. You need plans for maintenance and retraining.
You mentioned red teaming earlier. How does that differ from threat modeling?
Good question. They often get confused. Threat modeling happens early during design. It's proactive analyzing the architecture to anticipate potential threats and vulnerabilities before you build. Red teaming happens later, often on an operational or near-operational system. It's offensive, actively simulating real-world attacks like evasion, poisoning, extraction, to find weaknesses the developers missed.
So threat modeling is planning defenses, red teaming is testing them.
That's a good way to put it. Both are vital. You also need an incident response plan. What happens if the AI goes haywire? Is there a kill switch? How do you do root cause analysis? And finally, public disclosure and technical documentation. Things like model cards, think nutritional labels for AI describing performance, limitations, intended use, and system cards, which give a broader view of the whole AI system. Balancing transparency with protecting IP is key here.
And eventually AI gets old too.
Yep. The deactivation or replacement phase. Define criteria for retiring a model. Maybe performance degrades, risks become unacceptable, or it's just obsolete. Need a plan for safe transition, archiving data, and documentation for accountability, sometimes for many years.
Wow, that's a really comprehensive lifecycle view. But governance isn't just internal company processes, right? there are laws and external forces.
Absolutely. Technical governance is essential, but it operates within a wider legal and ethical landscape. Foundational privacy and data protection principles like fair information practices, FIPS, and privacy by design are baked into laws like the GDPR. AI systems processing personal data must comply.
And IP laws.
They apply too. Intellectual property. We mentioned patents usually require human inventors, Thaler v. Vidal. Copyright for AI-generated works is tricky. Lawsuits like NYTV OpenAI are testing the boundaries of fair use for training data. And trade secrets remain vital, hence concerns about leaks via AI tools like ChatGPT, prompting internal bans at places like Samsung.
What about specific sectors, like health?
Yes, sector-specific rules are emerging. In the U.S., the Affordable Care Act, Section 1557, directly addresses algorithmic bias in healthcare, demanding steps to prevent discrimination.
And general fairness laws.
Right. Fairness, non-discrimination, consumer protection. Think EEOC guidelines on AI and hiring, New York City's Local Law 144 mandating audits for employment tools, the Illinois AI Video Interview Act. The FTC can also penalize unfair or deceptive AI practices.
Who's liable if an autonomous car crashes?
That's the tricky civil and criminal liability question. Currently, existing laws often apply indirectly, focusing on human actors, manufacturers, operators. There was an EU AI liability directive proposed, but it seems shelved for now. There's ongoing debate about how liability should work for autonomous systems, with some, like US VP J.D. Vance, wary of overly burdensome regulations stifling innovation.
Okay, shifting globally, the EU AI Act seems like a big deal.
Huge. It's really the world's first comprehensive horizontal AI law. Its core is a risk-based approach.
Unacceptable, high, limited, minimal risk.
Exactly. Some AI practices are prohibited outright, like manipulative techniques, government social scoring, real-time remote biometric ID in public, with narrow exceptions, emotion recognition at work or school. Then high-risk AI systems, things like medical devices, critical infrastructure control, recruitment software, law enforcement tools face strict requirements before they can be marketed or used.
Obligations like risk management, data governance, transparency, human oversight.
All of that, yes. Plus, conformity assessments and registration in an EU database for high-risk systems. There are also transparency obligations for limited-risk systems, like chatbots needing to disclose their AI, and minimal rules for minimal-risk AI. And the potential sanctions for non-compliance are significant, based on global turnover.
How does the U.S. approach compare?
It's more fragmented, less top-down. Biden's Executive Order 1G110 focused on safety, security, promoting innovation, and advancing equity and civil rights. It directed agencies to create standards and guidelines. Other perspectives, sometimes associated with figures like Trump, emphasize reducing regulatory barriers to spur innovation faster. So, different philosophies at play.
And states are acting too.
Yes, we're seeing state laws emerge. California had SB 4-HAIL-47, which was vetoed but showed ambition. Colorado's SB 24-205 just passed, setting requirements for developers and deployers of high-risk AI systems concerning consumer protection and algorithmic discrimination. So a patchwork is forming in the U.S.
What about elsewhere? UK, China.
The UK has generally favored a more light-touch, pro-innovation stance, relying on existing regulators rather than a single new AI law, though that might evolve. China has specific regulations, too, like the interim measures for generative AI services, focusing on content control, security assessments, and provider responsibilities. Different priorities globally.
So laws set the rules, but how do companies actually implement them? Are there technical standards?
Yes. That's where technical norms and international standards come in. They provide the practical how-to. Organizations like ISO-IX have standards like 22989 for terminology, 24027 on bias assessment, and crucially, ISO-IS 42001, which defines requirements for an AI management system, basically, a certifiable framework for governing AI responsibly within an organization.
IE.
IE also has important standards like P7001 for transparency of autonomous systems, P7010 on assessing well-being impacts, P7002 addressing data privacy considerations in AI design. These standards translate high-level principles into actionable engineering practices.
Okay, beyond laws and technical standards, are there other influential frameworks?
Definitely. We have international AI governance frameworks and guidelines. These are often non-binding soft law, but highly influential. Think of the OECD AI principles widely adopted, focusing on inclusive growth, human rights, transparency, robustness, accountability.
UNESCO, too.
The UNESCO recommendation on the ethics of AI emphasizes human rights, diversity, sustainability, peace, and calls for things like ethical impact assessments. In the US, the White House released the AI Bill of Rights non-binding principles like safe and effective systems, algorithmic discrimination protections, data privacy, notice and explanation, and human alternatives.
Council of Europe.
They have the HUDRF framework, Human Rights, Democracy, Rule of Law Assurance Framework, and the HUDIRIA Impact Assessment Tool, focusing on AI's impact on those core values.
Yeah, there's a lot of frameworks. Is there one that ties it all together practically?
The NIST AI Risk Management Framework, AI-RMF, is probably the most comprehensive and practical one right now, especially influential in the US, but gaining global traction. Its goal is to help organizations manage AI risks and foster trustworthy AI development and use.
Trustworthy AI. What does NIST mean by that?
They define it through 7 core characteristics. AI should be valid and reliable, safe, secure, and resilient, accountable and transparent, explainable and interpretable, privacy-enhanced, and fair. Their definition of fairness is quite detailed, covering systemic, computational, and human cognitive biases.
And how does the framework structure risk management?
It uses 4 core functions: govern, establishing the culture and processes; map, identifying the context and risks; measure, analyzing and assessing the risks; and manage, treating the risks. It's a continuous life cycle approach.
What's really striking is, despite different laws and approaches, these core principles, fairness, transparency, accountability, seem to pop up everywhere.
Exactly. While the legal specifics vary hugely from, say, the EU to the US to China, there's remarkably strong international convergence on the ethical principles that should guide AI. Everyone seems to agree, more or less, on what good looks like, even if they disagree on how strictly to enforce it.
So we've covered a massive amount of ground today. From what AI is to the risks, the principles for responsible use, the whole life cycle of governance, and the complex web of laws and standards trying to shape it.
Yeah, it's a lot.
It really underscores that AI governance isn't just a checklist exercise. It's fundamentally about building trust, embedding ethics from the start, and maintaining constant vigilance. It's about protecting people.
And it has to be dynamic. AI isn't standing still, so governance can't either. It needs to adapt constantly. And crucially, human agency remains central. Developers, deployers, policymakers, ultimately, people are responsible for these systems.
Which leaves us with a thought, maybe. As AI keeps advancing at this incredible speed, how will our own definition of intelligence change? And what new kinds of governance, maybe things we haven't even thought of yet, will we need to invent to make sure this powerful technology truly serves humanity's best interests, not just efficiency or profit? Something for all of us to think about and maybe even get involved in shaping.